Okay, so here's our question. We're told to show that Rn equals R1 plus R2 over A plus 1 for an inverting op amp. So let's start by drawing the inverting op amp. So I'm going to draw this a little bit differently from the way the book shows it to kind of help make it a little more intuitive. We're going to put both of these resistors on the same line. And I'm doing that to remind that the current coming out of this voltage source, the current caused by it, it's going to hit both of those. And this is going to go here. So this is our negative terminal, this is our positive terminal. It's part of what makes this, well, it is what makes this as an inverting op amp, is that we have voltage source coming to the negative terminal, and we have tied the positive terminal to ground. Okay, so this is V out, and this is V in. And this is R2, and this is R1. Okay, so first things first. How are we going to get to this? Well, actually, what is this? What is Rn? Rn is the voltage, the resistance that comes with this voltage source. It's not in the circuit, but it's there. It is present. So knowing that, keeping that in mind. My cat is meowing at my dog. Great. We're gonna start with voltage out. So we need one of the laws of ideal op amps. We need the law that says no impedance on output. Well, what does that mean? What does that get us? So what that really means is that there is nothing changing the voltage between here and here. Well, what causes the voltage here is we've got a little gain circuit here, and its gain is A times V. Its gain is the voltage at the positive terminal minus the voltage at the negative terminal times the gain factor. So basically, we now know that V out equals A times VP minus V in. And just to make it memorable, this is V positive, this is V negative. So something should strike you as funny here for this specific circuit. We have tied V positive to ground. This means that V positive is 0. So in this circuit, V out now equals minus A times V in. So after getting that, we're going to look at the loop here. So we're going to start with this voltage. The voltage here is V in. The voltage here is R2 times some current. What's some current? We already talked about that. That current is IN. And then we got the voltage here. That voltage is V out. So 0 equals Vn minus R2In minus V out. So V out, if we solve for it, equals Vn minus R2In. So now we have 2 terms for V out. This means we can solve for something. What we're going to solve for is Vn, the like term. And that's going to come out, and you'll want to show your math on your homework for it, but that's going to come out to Vn equals R2In over 1 plus A. So this should look really close to what we're looking for, but it's not quite there yet. So what are we going to do now? What we're going to do now is take a look at this loop. We're going to start at Vn, and we're going to say, we'll do it here, Vn equals In, R1In plus V neg. So, now that we've got that, we happen to have a term for V neg. So, let's plug that in. Vn equals R1In plus R2In over 1 plus A. Alright, well, factor out that In. And we've done the bulk of the work. So, what we have here is mostly what we want. Now, we also have this voltage and this current in the way. Well, that should set off your Ohm's law sensor. What can we write that gets an In on both sides that we can cancel this out? And oh, by the way, leaves us with a resistance when we do that. Well, we're going to go back to this mysterious Rin resistor. We have the voltage, the resistance, and the current for it. Right? So, let's just say that Vn equals In Rn. So yeah, let's just plug that in, right? So there you go. That's it. It's absolutely ridiculous. And like so I remember doing this problem when I took this class, and I remember having hell from it because it's really abstract, and that doesn't look like anything we've seen. It doesn't look like something we should be able to get. And what the heck is this gain mess? It comes down to understanding enough of the inner workings to be able to take that step out and work with the outer workings of it, to be able to abstract the concept. And I'm gonna try, I don't know how well it's gonna work out, but I'm gonna try and create a video of like op amp crib sheet to make this easier, because op amps are wild. They're ridiculous. And on average, you're not gonna have to build them. Op amps are absolutely the hardest part of this class too. So once you can get this, everything else is gonna be just smooth sailing pretty much. So let me know if there's anything specifically you want me to dive into. If you have any questions that, even if you don't think they're gonna come up in class, if you're just curious, just let me know. I will do my best to answer it and to try and work it into video, and yeah. So hopefully that helped. Hopefully that, like, starts an understanding of how to harness these really arbitrary and abstract laws of ideal op amps. Because that was part of the hardest part for me, figuring it out. But I'm gonna stop rambling. Hope you have a great weekend.